Oh, okay. We'll hear that every single day. Let's tone her down a little bit here. Okay. Zoom, zoom. For an example two, is that what we stopped at? Do we do B as well or no? We did B. B right there. Let me go back. We did D, right? The H, G of H plus H. Da-da-da. We did the determine if this is a function. And you guys talk to me. How do we determine things are a function?
Has to be a different y value for each x.
Perfect. Yeah, we have this little issue that if you plug in an x, let's say 0 here, right? What you're going to get is you're going to get two different y values, a plus one and a minus one in this case. So the issue, it really is this little 2. If y has an x squared next to it, in fact, it has a y to the 4th, to the 6th, or any even power, then that can't be a function because when you solve for y, you're always going to get an even and odd functions. Okay,
good there. There's a different value for each x or each y.
Multiple values for y based upon a single x. That's our problem. Does that help, Miles? Yeah. Cool. Okay. So now let's jump to something that we have not heard of before. I don't think so. It's something called piecewise functions. And let me just take a look at the homework real quick here. Okay, just checking. Okay, so we have functions. Check something just real quickly here. Function notation. Okay. And jam. So piecewise functions. What in the world are these guys? These guys are two or more functions kind of fit together. So how about something that looks like this? So kind of funny here. So if we did this here, then we're going to do A here. I need you guys to find what in the world is. C F of 4. Cool. Let you copy it down and then do it if you think you know it. Go for it. Jada, you can just unlock the door itself. That's fine. All right, we'll let keep it in. Cool. All right, so this is broken up. It's a piecewise function, which is it's in pieces. That's it. So what happens is if you are using x values that are less than 0, what we do is we use this function for it. If the x values are 0 or bigger than 0, that means we're using this function for it. So just depending where the x is, use the different types of functions. So f is -2. First one, top or bottom? It's the top function here. So -2, we're going to use the square function and gives us a 4. How about f of 0? Bottom function, because that means greater than or equal to 0. So 0 is equal to 0. That's cool. 5, top or bottom? Bottom. That's cool. And then it's just x itself. So that's no problem here. That's just this one. and an f of -10. Top.
So does this holds true for like every problem? X squared.
I just gave like x squared. It could be x squared plus 7, right? And the bottom one could have been x minus 3 or something, right? But you set 2 different functions or 3 different functions or 4 different functions, right? And then you set the conditions of where they do.
Okay. So just to clarify, so f next to -2, that the -2 is f or is x?
The -2 is x. And then we look over here to see which one are we going to use. Because it's a -2, then we start using this one.
Okay, but like why? Like, why do we have these piecewise functions?
Kind of fun. Miles, I like your questions. So let's go. Where are piecewise functions used at, right? So let's do this here. Yeah, there we go. So let's do one example here. The IRS tax code, since I was doing my taxes the other day. So whenever you make, I'm going to graph it good in terms of that. But if you make a certain amount, no, don't want to do it that way. I could just do T for taxes, huh? That'd be fun. T for taxes. If you make up to $100,000, let's say, right, you are taxed at 15%. So it's just straight up 15%. X is less than or equal to 15%. Okay, 100,000, right? Once you do that, in fact, I'll probably even bring in, I think I should find the tax code of like the functional. So once you break $100,000, you go on to the next level, which now you're taxed at that little extra piece over 100%, 100,000, you're taxed at, let's say 20%, we're good? So notice as it increases.
$1,000 a year.
Generic, I don't know the exact tax code. I'll look it up, that'll be interesting to see. So it looks something like this. So notice this is X. You guys don't need to write this down. This is just an example here. We're going off what Miles had just said, and we're going off on a tangent. This is all because of Miles. Let's say up to 150,000. So this is the tax that you get up to 100,000 right here. And this is the extra tax you're going to get at 20% now that you cross the $100,000 threshold. And then it goes on. Then after you pass 150, then you're at 25%. So now you're like this, 150 plus the 20% tax on the remaining part here, and then you're still going to have the 15 here. Does that make sense, Miles?
Okay. Yeah, so what this means is when you see like E times X, you convert it into like if you have.
Depending where X lands. So if X lands at, you're making $20,000 a year, you're not going to use this one because that's your tax at 15%. That's not where you're at. You are here. You are between 100,000 and 150,000. So you're gonna have to use this function for the equation. That makes sense.
So if X equals 120,000, 100,000, 50,000.
We're gonna use the middle equation to find our tax bracket.
What do you do with that?
All you do is just plug in 120,000 into here, and that's it, because it'll just be one equation. But note that you have a selection of which equation you need based upon how much you make.
So the answer is 0.2, 0.20.
The answer would be 120 times minus 100,000, so it'd be 20,000. 20,000 times 20% of anybody. What's 20% out of 20,000? 4,000. 4,000 plus the 15,000 that you made because you were over 100,000 already. So you paying 19K for your taxes based on that. Talk to me if that makes sense. Let me give you another example and we'll go from there. Is that maybe going off? Mike?
Like just a general example, something like that. Piecewise function. It's basically giving like, if then, if and then like, then that like.
Yeah, absolutely. Yeah.
And it'll just be like,
If the input is less than this, you use this one. If the input is in the middle here, use this one. If it's greater than that, you use that
if
one.
input is this, then do this. And it's kind of-
Yeah, absolutely. Computer science brain, yep. That's
So
cool.
it's like,
Huh.
it shows you what X is, but the merit of the piecewise functions is that you have like a wider range of, like, there's a specific range of places where that can be, yes, right? Because like, you've got the 100,000, there's a specific solution for that, but the next one is 100,000 through 150,000. So the merit of the piecewise solution is that there you can make it so that there's a specific range where you can solve these problems.
Yes, and for specific range, the condition is different. So up to $100,000, you only pay 15% tax and you're done. But then after 100,000, you don't pay 15%, you pay a higher bracket. So because you move into a higher bracket, you have different rules now for that bracket. And then it keeps on going.
Is there a way to graph this kind of equation in the calculator?
No, not on a calculator. Because the calculator, when a calculator does it, they can only graph one function at a time. Right? And then you're sort of done. Let's see. Maybe cell phone bill would be another example, right? Data usage on a cell phone bill. Let's say this here. Let's say up to 5 gigabytes. You got a 5 gigabyte plan, and let's say you pay $45, right? Okay, so up to 5 gigs, it's all great, but then afterwards, what you're going to do is you're going to pay per gig usage, right? So notice this equation was a flat equation of $45, but then afterwards, you're going to be doing this. So notice the graph itself has changed, right? Instead of going one way, now it's turning to go another way.
So the way that so the difference with the piecewise functions is that when you graph these, it's like a stair.
Sometimes a stair, yeah,
Kind of like a,
could be,
jagged.
Yeah, it'll be like jagged. So let's say that the IRS tax code, right? 0 to 100,000 goes like this. Then afterwards, it's gonna be a little more steep, right? Because it's gonna go like that. Because you're making, now you fit a certain, then the next one is gonna be even more steep because you're making this much money. So notice it's not linear anymore. It's not one single function. It's like broken up into pieces.
Okay.
Oh, cool, guys. You know what this is? This is so cool. Real quick here. Air resistance. Did you guys know when we go through the atmosphere? Anybody know how many layers of atmosphere we have?
7?
Good. 7 is good. Seven layers of atmosphere. So
more than one.
we are on the ground, and our atmosphere level as you go, our atmosphere air resistance is like this. And then what happens is when you reach, I don't know where, but the air resistance actually changes. It goes like this. And then once you reach a different block, it's like this. It's the craziest thing. And so 1, 2, 3, I can go on all the way to 7. But here's air resistance. So at every single stratosphere that we have, the air resistance per height, right? Because this is the height inside this area here.
It increases for a bit and then it goes down.
Each stage has its own air resistance level. So like that one, I got to take it all the way to here though, right? So let's say it's this one, and then from here, then it drops down all of a sudden, and it goes like this, and it's the strangest thing. You think the air is all the same, right?
No.
You reach it. So rockets have to account for that as they go. And where's the best way to?
That's how you graph it. You don't put like straight lines in between.
You can't. Yeah.
Yeah, because there's like.
So then this guy's.
We're like a straight up line.
So piecewise function would say, let's say this is 100 feet or something like that, right? Let's just say it's 200 feet, 300 feet, and we'll go through. So then the function for air resistance would be whatever this function is. And then we'd have a condition that says anywhere from 0 to 100, I'm going to use this formula. But if I don't need to write this down either, but if I go from, if I'm in the $100 to $200 level, or that one, then I'm going to go, then I need another formula to count the that line. We're good? Does that make sense? You guys agree that? Did I beat that to a dead horse yet? Okay,
Yeah, I understand.
cool. Okay, let's jam. So piecewise functions is just multiple functions based upon the conditions. That would be good. And please, I like you guys like speaking through it. Please do. Okay, this is part of learning and going through stuff here. What example are we on?
That's a great question.
Example 3, I think.
Oh, I'll go with that.
Look at our notes here. This is before the piecewise functions. Example 2. Okay, so I'm going to give you guys a series of questions now. Example 3. Find all values of x such that f of x equals 0. And we'll do 1 or 2 examples. We'll see how far we go. Let's do an easy one here. So this is just getting used to the notation. That's all. So find all values of x such that f of x equals 0. Interesting. Okay, so for this one here, does this make sense here? So if f of x equals 0, all we do is we just do this. And we solve. Are we good? Da-da-da. My
Okay, yeah,
goodness.
when you start in that, because when you say f of x equals 0, I'm like, well, does that mean that, like, it feels like, it looks like you're replacing both x plus 1, but, so you just, it's kind of just like, okay.
Yeah. Cool, cool. And the distinction would be like this right here, right? If this was f of 0, that means you would place the 0 in for that. But the question is the other way. Okay. So let's see. -1 rolls to the other side. Is that right? Divide by x or divide by 5. Sorry, we got ourselves a -1/5. Are we good there? Cool. So let's see. Since we know factoring now, I have to give you guys a factoring problem. Cool. And I usually look to see how you guys are doing. If I see some people still writing stuff down, I'll wait a little bit here.
F of x is different than just x. It's like you multiply x by 0 and it's 0 on the left side, but you multiply x by 0 on the other side.
So yeah, the distinction
It looks
here.
like you're setting x to 0 on the left side.
Yeah, for I just kind of clarified it here. So if I say, what is f of 0? That means what we do is we plug in a 0 into x. If the question is, when does f of x equal 0? We plug in the 0 for this whole thing here. And we start solving. So then the question is, what x values make it happen is -1/5 x value.
So there's nothing on the left side. F of x equals 0.
Let me do one more example. Let's see if this helps, and we'll back up to this one if need be, okay? B. Example B. I need to know this one. I need to know, when does f of x squared plus or minus 8x plus 15. Okay, when does f of x equal 0? What values for x make this 0? I guess I need to find out, right? So what I'm going to do is I'm going to plug a 0 in for all of this. So what x values make f of x equal 0? Don't know, but I think I'm going to do factoring over here. Anybody help me factor? I need
X in both.
X in both.
-3, -5.
Oh, awesome. I'll go with that here. -3, -5, or -5, -3, doesn't matter which. All right, I'm gonna do it I'm gonna do it the long way, and then we'll figure out the short way to do it. So that means that I have X. Let me turn it around, because I always like the other one turned around. I like it like this. Okay, if I can turn this around real quick. Put the 0 on the other side. Good. Ben allowed me, so that's good. So I'm going to say X -5 = 0 or X -3 = 0. I solve each one of these guys here. So I got myself X = 5 or X = 3. Are we good there? And at this point, my OR statement turns into an AND statement, which means, hey, what are the X values that when I plug them in, it'll give me a 0? The answers are 5 and 3. Are we good?
So to figure out what values of X are 0, and you just plug 0 into the left to the side of the equation of X is on, and then you just solve.
Mm-hmm. Absolutely. And I'll give you a little more. Let me just wait just a little bit. So guys, that was the long way right here. Anybody seen a short way? I went from here to here to here to here to here, then eventually to here. Ethan.
You can look at the factory and like the X -5, X -3 and figure out that if you have like
Yeah, can we go directly from there to there? Absolutely. In fact, please do that as opposed to saying all that. In fact, can you even go from here to here? Let's see. You go from here to here. Oh, that is so cool.
No, I don't think you should.
No, not for Ben. Ben can't do it.
It doesn't make sense. It's science.
Okay. So we go from here to here then.
I mean, if it's a positive, you make it negative. What if those numbers were decimals?
I mean, they are positive, they just wouldn't subtract. If they were negative, they're negatives, so they would be that.
If those instead of 5 and the 3 were like decimals, you make them 7, or you just make it negative.
Yeah, still change the sign and you're done. Yeah. Okay, next one. Of course, I'm going to make it more difficult because that's the fun part about it. Oh, I think we remember this guy here. Expert. Oh yeah, I think I remember this. Go for it. So we're just practicing with function notation, right? And we're just practicing what, bless you. We're just practicing with what does the wording say to what it means. We good? So what X values would make this guy or f of X be 0? I don't know, but I know that I make this into a 0. And I think I can solve this. Oh, anybody know how to solve this? The grouping method, okay. Plus in the middle at first, and then we move everything over. Negative 4x plus 4. All right, what goes out of the first parenthesis? X squared, awesome. Right, the leftovers will be x minus 1. What goes out of the second parenthesis to make another x minus 1 parenthesis? Not a 4. Negative 4, okay. X minus 1, perfect. So then, mathematically speaking, then I'm going to factor out an x minus 1 out of each of these. We good? So x minus 1, in a sense, almost like they go out to the front. So there. And now the leftovers. And the question is, can I factor down some more? X squared minus 4 is same thing as, and here's my,
What else?
what are you doing?
Plus minus X plus 2.
Oh, no.
Thank you. X plus 2x minus 2. Okay, and then from here, instead of setting it equal to 0 and doing some more, we're going to just say x is equal to positive 1, negative 2, positive 2 is perfect. There's 3 times where this guy gives me a 0.
And so we subtract x. One, two.
Yeah, so let's go with Eli's question here. We can set this guy x minus 1 equals 0, but you can think about it as, what do I plug into here to make this guy to be a 0? Right? It's a 0 because once I multiply by 0, who cares about everything else? 0 times whatever numbers here will still be 0, right? Okay. So just getting used to notation and talking about the notation. Okay, another one. Exercise 3. How about this one here? I'm going to say this. Find values of x such that f of x equals g of x. Okay, and then the question is, what does that mean? 4. Yep. Okay. All right, talk to me. What do you guys think?
Does fx equal f equals 0 still?
No, now we want to know, find the values of x such that f of x is going to be the same thing as g of x. What does that mean? And how do we do it? Perfect, yeah, so instead of, so it's the f of x, this little piece right here, that's going to come down as this piece. And the g of x, it will be changed into that. Are we good there? Here's my f of x, here's my g of x.
0, we just plug in 0.
0 to work. Now the question is there any other thing that works? Okay, how do we solve this? Can't factor yet. I think in order to factor, I have to have this set equal to 0 first. Is that right? Perfect. I'll go with that here. Subtract that. Let's move things over. I got myself x to the 4th. That was not affected, but this is 4x squared. Is it? But yep, equal to 0 now. So I'm running out of room. So I'm going to go up here. Next, you guys talk to me. What should we do? Right? Now we can factor, right? That was the whole point of getting it to 0. And what's the, CGF, right? Greatest common factor is x to the second power is perfect. Yep. I can take those out. We'll be left with x squared minus 4. Is that right? I think so. Okay. Perfect. And let's see. Oh, I'm not factored completely yet though. So how about x squared? X plus 2x minus 2. I think we did that one already, right? Ooh, that'd be interesting to see something. That's cool. All right, what are my zeros? 2 and negative 2. How about that x squared over there? Yeah, if I square something, let's say the 2 was not there. If it was just x, right? X would be equal to 0, right? If I square it, x squared is still equal to 0, right? Because 0 times 0 is still 0. If it was a 3 or a 4 or 5, who cares, right? All of them would still be 0. So x equals 0, negative 2, positive 2. And so there's 3 times where that happens. Okay. So guys, we just finished at 1.4. That's all we did. So we are definitely going to scoot the test over. Okay, you guys talk to me. Another one like that or no? Or are we good there? Just setting. Sure. So it's 4. Gotcha. Okay. Any question? Sorry. Okay, did you guys talk to me? Did we ever do domain in this class before? Domain.
It sounds
familiar, but we
extremely
didn't do it.
We read
Okay.
it in the,
Okay, like finding domains of functions. Okay. So let's go. Sure.
question is that, class to go beyond that culture.
Now, yeah, not yet. No, no problem. Guys, chapter 1, sorry guys, it's just like stuff that we kind of should know from algebra 1. It's the boring stuff. We'll get into some cool stuff.
a lot of it.
Weird. My screen is funny, okay. I'm gonna turn, guys, because my screen turned funny over here. Let's see if I can go from here to here. All right. Jamin, let's talk about domain. From algebra 1. Did you guys ever talk about domain in algebra 1?
Yeah. I don't remember.
Okay, so let's talk about, so one thing, look at this, this would be a kind of fun thing to do here. So fractions. Go.
Is domain in section 1.4?
Still 1.4. That's the last part of 1.4 finally. So we got fractions, guys. Fractions are a problem with domain. And domain is, if I plug a number in for x, right, it should give me a number out, right? So domain means number for x gives me a number for y. That's what I want. Or in this case, f of x. So let's do this one here. Let's see. I'm going to define a function. Let's say f of x equals 1 over x plus 2. I have a function that looks like that. You good guys? Am I in your way? Sorry. So here's a funny thing. So if I were to plug in a 1 into here, is everything fine? 1 plus 2 is a 3. Notice what happens is I plug in a 1 in for the x and I get out a 1/3 for y. Is it good? My domain, everything's fine. A number in for x produces a number for y. Oh, there's my clock. Okay, so this one here, you guys tell me what the answer would be. One seventh is good. Everybody agree with 1/7? Awesome. Easy stuff, I know. So we can put negative numbers in 2 as well. That's fine. So ooh, cool. I go with
So the reason these are the answers for y is because there isn't a defined function for y.
so this is my function right here, right? And I just kind of just set it just like this. I'm gonna have to add a little something here, just a second here. So if I plug in a -2, all these numbers work. A 1 works, a 5 works, a 12 works, -14 would work, right? But when I plug in a -2, here's what happens. I get this. And this guy is not a number in mathematics. That's like a weird thing in mathematics. So what we do is to put UND for undefined. Yep, go ahead.
What does it say right next to that?
Domain, number, is it like a number sign? Like that, number sign for x. So a number in for x gives you a number for y or fx. Okay, so this guy, what is the domain of this function? Because of that little piece right there, we're gonna go like this, negative infinity to a -2 bracket, or sorry, parenthesis, union to infinity. So the domain is all the numbers except for 2. Let me just check the back. Make sure that's the way they write it. So I'm not telling you guys something different.
Oh, I kind of remember this.
Okay, the way they write it is all the numbers except. So they write it like this, all real numbers
And that isn't a coordinate, that's just like a list of all of the numbers.
except x is equal to -2. Does that make sense, guys, there?
Yes.
Fine.
Okay. Didn't look at all of it. This reminded me that we did in the other one. So, like, if you had a line, another line. This is hard to describe. When we did, as in Mr. Sam's class, we get that, and then we put this light and an arrow to show like where those numbers would fall. So it would start at -2, like negative infinity, and then you start at up to, and then all the way to infinity. So then where.
Yeah, usually we'll do that with inequalities when we get there. Yeah, but that's the start of it. What we're saying is if you wanted to graph it, because we don't normally graph it though. We're going to -2 here, open dot. And we would kind of do this right here. And that's a graphing answer to it. That's kind of like the verbal answer, and this is called the interval answer. So those are all the same thing.
Line, this one's
Cool. Cool. Okay, fractions are a problem because of that right there. We good? Let's jam to the next one with 4 minutes left. Go, Jay.
It's all those numbers except x equals -2, why can't it be 2?
Yeah, if I plug in a +2, everything works because if plug in a +2 would be 2 plus 2 on the bottom.
Well,
Well, that's because
something you
you
can't.
can't because it's undefined.
Okay, so this is not, yeah.
Good.
What was the method that you were saying that,
I was just wondering about that.
Why is it
destroy the fabric of the-
That's called interval notation.
Is that saying that -2 and -2 want to be intervals?
I'm saying all the numbers work from all the way from negative infinity, but when you get to -2, we cut it off. And then we start after negative. Oh, sorry guys, real quick here. Thank you so much. Hey guys, real quick here, I made a mistake on the board. If you guys can put a negative right here. That's what it was. Sorry guys, that's where you guys were all looking at me weird.
Alright, that isn't a coordinate, it's just like a list.
It is, it's kind of like this. We're saying everything works here, everything works, and then right at that point, it does not work. And then everything works.
Alright.
That's why, okay. That's what I'm saying. Didn't make sense when I said there's an interval there. That's just a single point that does not work. Guys, 2 minutes left. Let's finish this one. Fractions is a problem, and square roots are a problem. Square roots, or we can call it even roots. Even roots are problems. So let's do one like that as well. So I have f of x equal to the square root of x plus 4. And there'll be some tough one in the homework on this, but I'll kind of leave it for you guys to try first, and there'll be a question with time left here. So when is this a problem? Is when you have negatives inside this. So we can take square root of positive numbers, we can take square root of zeros, but you can't have, and I'm going to say this, is the square root. I'll just put negative in there. Not for real numbers. We have figured out a way around it, but not for real numbers. So you can't have a negative inside the square root. So all we do is we just say this. We say, you know what? We're gonna take the inside stuff here. I'm gonna say, hey, when is this true? When is that little expression gonna be greater than or equal to 0? And if I subtract 4 from it, I'm gonna get this right here. Almost at a class time. Let's see, 58 seconds left here. Let's see what the answer says. Okay, all real numbers such that, okay, so then it goes like this. All real numbers such that, and it says x greater than or equal to -4. That's kind of the answer, the way to look at it. And another question.
Is this on 1.4?
This is on 1.4.
Okay.
Yeah, we have not even touched 1.5 yet.
Did we finish 1.4, so homework?
Yeah, so 1.4 homework, you guys can finish the rest of 1.4 homework. We finished up 1.4 today. It will be due on Friday. Cool. Otherwise, have a good day. Interval notation. Let's see. It'll just be. So we're including the -4 as part of our answer, and then we're going high. All right, out of here, guys. Have a good rest of the day.
On Google Classroom.
Okay, cool. Okay, gotcha. Then I'll take a look at it.
I just wanted to let you know.
Thank you so much for telling me.
I just wanted to let you know.
Sounds good. Thank you. Homework is said.
Hey, my man.
So the factoring section, you just have a lot of mistakes there. So if, I'm gonna do a video on the factoring section as well.
Wait,
I think
so
there's
you're
a
gonna
video.
post it on
I will post it on a YouTube channel. Once I set it up. But if, let's see, I wanted to ask you here, are you getting it now? You just didn't get it earlier, or is it just?
Yeah, it's making a lot of sense.
Okay.